the simple spending multiplier and the multiplier effect. Today, we're going to explore what happens to our equilibrium real GDP in our income expenditure model when there's a change in spending. We'll start by constructing our model and adding in the aggregate expenditure or AE function. Let's assume that our initial equilibrium is at $4,000. If the AE function shifts, that will change our equilibrium real GDP as well. For example, if spending increases and the AE function shifts up, equilibrium real GDP would increase. If spending decreases, the AE function shifts down and our equilibrium real GDP will decrease. So the question is, for any given change in spending, by how much will our equilibrium real GDP change? For example, if spending increases or the AE function shifts up by $100, by how much will our equilibrium real GDP increase? Who knows? Actually, the change in equilibrium real GDP brought about by initial change in spending depends on something called the simple spending multiplier, or just the multiplier for short. In fact, our equilibrium real GDP will change by a multiple of the change in spending. That brings us to what I like to call key equation number 1. We'll use this equation to calculate the change in equilibrium real GDP when there's a given initial change in spending. We'll take the initial change in spending times the multiplier, and that will give us our resulting change in equilibrium real GDP. For example, suppose the multiplier is 4 and spending changes by the $100. Then our equilibrium real GDP will change by $400. The $100 change in spending times the multiplier of 4. Notice that because of the multiplier effect, we assume the multiplier always has a value greater than 1. The resulting change in our equilibrium real GDP should always be greater than the initial change in spending. What if we're not given the value of the spending multiplier directly? Then we'll need to use what I like to call key equation number 2. The multiplier is equal to 1 divided by 1 minus MPC. For example, if our MPC is 0.75, the multiplier would equal, again, 1 over 1 minus MPC, which would equal 1 over 1 minus 0.75, which equals 1 over 0.25, which equals 4. Then we'll use this result of 4 and plug that value back into key equation number 1. It may help to think of the multiplier effect in terms of a ripple effect throughout the economy created from that initial change in spending. For example, suppose that in Springfield, USA, Lisa Simpson decides to buy some new saxophone reeds that will cost her $100. This represents an initial increase in spending of $100. In our model, the AE function would shift upwards by $100. When Lisa spends the $100, this will become new income to the person who sold her the reeds. What would that person, let's say groundskeeper Willie, do with a new increase in his income? He would increase his consumption spending, since consumer spending and disposable income are positively related. But would Willie spend the entire $100? Remember, we assume there are 2 things we can do with our disposable income: spend it or save it. So he would not spend all $100 because he's going to save some of it. Now, what again tells us the proportion of any change in income that we would spend? That's right, the MPC, or marginal propensity to consume. Let's suppose our MPC is again 0.75. This means that Willie would increase his spending by $75. The $100 increase in his income times the MPC of 0.75. And let's say he spends all of that on artwork created by Homer. The $75 he spends will become Homer's new income, of which Homer would increase his spending by, you guessed it, 0.75 of that, or $56.25. The $56.25 he spends will become the next person's new income, of which that person would increase their spending by 0.75 of that, or $42.19 approximately. That's the 5625 times 0.75. This goes on and on and on. So if we were to add up all the rounds of spending that we've created in this example, starting with that initial $100 change, how much in total would we get? 100 plus 75 plus 5625 plus 4219 plus 3164 and so on winds up to equal $400. How do we know it's going to be 400 exactly? Remember, we're assuming an MPC of 0.75, so when we plug that into key equation 2, we get a multiplier, again, equal to 4, and plugging our multiplier of 4 back into key equation 1, we get the $100 increase in spending times 4 results in a $400 increase in our equilibrium real GDP. Now what would happen if we assumed a different MPC? For example, what if the MPC were 0.9? Or what if the MPC were 0.5? Well, if the MPC were 0.9, we'd have a multiplier of 10. And if the MPC were 0.5, we'd have a multiplier of 2. You should note that as the MPC increases, the value of the multiplier increases. In other words, the ripple effect is bigger because people are spending a higher fraction of their new income. And as the MPC decreases, the value of the multiplier would decrease. The ripple effect will be smaller because people are spending a lower fraction of their new incomes. That concludes our video lesson for today. And as Homer might say, woohoo!